Here is my second portion of my second DER in my grade 12 year, the CHUMP Final, a project consisting of the entirety of the CHUMP 4-bit computer build, except for the clock circuit. Throughout this video, I will go over the build, explain how the computer works, and then move on to the code portion of this project. Finally, I will explain my revisions of my Pascal's triangle solver code and highlight the custom user function I created within set code. Firstly, how it works. The way I like to think about it is similar to a human. The clock signal is the heartbeat, the program ROM is the thoughts, control ROM is the neurons, ALU is the brain, RAM is the memory, and everything else is supporting. So, for example, say the simplest of functions is called upon, 000000001, or better known as load1, a function which loads the number 1 into the accumulator. To even call such task, the program counter would have counted to the specific line within the program ROM in which the function was written. Next, the program ROM would output its high nibble 0000 to the control ROM and low nibble 0001 to the multiplexer. From there, a high nibble inputted to the control ROM is read, and outputted is the code written on line 0000. In this case, 1001, 1010. The high nibble represents mode, carry, accumulator, and read-write, where the low nibble represents select lines 0 to 3. Moving back to the multiplexer now, that the low nibble is 0001 is received, and the select line is low, the low nibble's values are fed directly to the ALU. Using the control ROM's 4 select lines, carry, and mode, the function f equals b is found, in this case, being the output of the multiplexer, a 1, or in binary, 0001. Finally, f value is uploaded to the accumulator, displaying a 0001, accomplishing the goal of the load1 function. Don't get me wrong. Despite this being the most straightforward function on the CHUMP, I would not expect the untrained eye to fully comprehend what just occurred, but do hope to make one thing clear. Despite the fact it may seem as if there is a ton of gray area, there isn't much. In the CHUMP, everything is black and white, from the 1s and 0s in the code to the 1s and 0s displayed through the LEDs. Secondly, onto the software portion of this project. I will explain my custom code and a custom user function in set portion. The V2 version of the basic 16-line code was used to solve 2 to the power of n, or better known as Pascal's triangle. My original code on screen worked within my testing through the CHUMP VM, yet I overlooked one problem. Before running every code, I changed the value within the accumulator to satisfy the line on Pascal's triangle I desired to be solved. Theoretically, something like that could be accomplished within the CHUMP using an external program counter and a few wires, but was not practical as I wanted my build to be completed within 4 breadboards and only came to this conclusion late in my build. So, instead I decided to alter the code, moving the final load function to the beginning, accomplishing my goal but at a cost. That being the absolute value would need to be read through the multiplexer. So, now, for the demonstration, here is the V2 code running with the initial load function being a 3, therefore outputting the final value of 1000 in binary, or 8 in base 10. Moving on to the final portion is my custom user function, bit shifting, and how I went about creating it. By no means do I expect everyone to understand bit shifting. So here is a demonstration. Say you have the value 3 in base 10 or 0011 in binary and decide to bit shift it once to the left. The binary value will become 0110 or in base 10, 6. Hence, bit shifting a value once to the left is essentially just doubling it. Anyways, to accomplish such task, the function f equals a plus a must be used. According to the chart, the select lines must be HHLL, must be high, high, low, low, and mode must be low, and carry must be high. Therefore, with a slight change to the control code, this is accomplished.